The last half-century has been a golden age of astronomy and cosmology. Technology and the technology has enabled us to transform our understanding of the universe. And during that time, 2 BBC shows have been alongside every step of the way, Horizon and Sky at Night. Now, when Sky at Night first launched, Sputnik 1 hadn't even gone up yet. There wasn't a satellite up there. NASA hadn't even been invented yet. I want to start by showing you a clip from Horizon's first show. Space at that time was literally the preserve of science fiction. And in Horizon's first year, a show went out called The Knowledge Explosion, where Arthur C. Clarke made some fantastical predictions about these newfangled things called satellites. Can we play clip 1, please?
I'm thinking of the incredible breakthrough which has been made possible by developments in communications, particularly the transistor and, above all, the communications satellite. These things will make possible a world in which we can be in instant contact with each other, wherever we may be, where we can contact our friends anywhere on Earth, even if we don't know their actual physical location. It will be possible in that age, perhaps only 50 years from now, for a man to conduct his business from Tahiti or Bali just as well as he could from London. In fact, if it proves worthwhile, almost any executive skill, any administrative skill, even any physical skill, could be made independent of distance. I'm perfectly serious when I suggest that one day we may have brain surgeons in Edinburgh operating on patients in New Zealand.
Back then, that seemed bonkers, but it was incredibly prescient. Now, I will say this, he was a year out about surgery. The first remote surgery actually happened in 2001 with a surgeon in New York operating on a patient in France. But that's pretty impressive. Now, since then, satellites have transformed our world and have transformed television. We now live in a world with multiple channels where science communication is available to all online, and there's an entire generation who barely watch telly. They're all online and on their mobiles. So what does that mean for big strands like Horizon and Sky at Night? Now, we are in an era of unprecedented change, and I don't really know what's going to happen in the next 3 to 5 years. But at the moment, those 2 strands are holding their own and doing incredibly well. The last big Pluto special that we did, we doubled the audience of Sky at Night on BBC 4. Similarly with Horizon, we've been up against Bake Off this year. Not brilliant. But again, we've doubled the slot that was the audience that was expected in that slot. So whatever we're doing at the moment, it's working. And I want to give you a bit of an insight into what we've been doing over the last year to keep Horizon and Sky at Night evolving and changing as we go forward into this new era. Now, for any television show, there are 3 things that you need that are absolutely key. The first one for us is the content. It's the science journalism. It is absolutely key to what we do. Is there enough revelation? How important is the science? Is it good science? And we all know from MMR scandals that it's really important that us science journalists get that right. The second thing, critical, is story. Why should your audience give you 10 minutes, 30 minutes, an hour of their time? Why should any of them care? And the third, it's the telly bit, the form. Is it a live event? Is it a straight observational documentary? Is it a scripted drama? All of those 3 things are absolutely key to making a good telly programme. Now, I want to start by telling you about a film that was an absolute no-brainer for us to make. And it starts with a story. It starts with a mystery story. It became clear, in over 50 years of space exploration, we've been to almost every corner of the solar system. We've sent probes to the sun, we've sent probes to the outer edges of the solar system with Voyager 1 and 2. We've been to Mars 43 times, although over half of those have failed. But there was one little rocky, icy planet, or dwarf planet, that we haven't been to yet. And when when we knew that New Horizons was going to be going there to get pictures for the first time, what would they find? We knew our audience would be interested in that. It's a no-brainer that we're going to cover it. And I want to show you a clip of how Sky at Night decided to cover this early this year. Can we play the next clip, please?
3, 2.
The revelations about New Horizons' visit to Pluto last week made headline news.
Scientists have tonight been celebrating the arrival of detailed images of Pluto.
Here at the Sky at Night, we've been lucky enough to be behind the scenes, following the unfolding story every step of the way.
We've recorded data of the Pluto system, and we're outbound for Pluto.
Revealing the in-depth science behind the incredible images of Pluto and the surprising discoveries of mountains and strange geometry on the surface of this cold and distant world.
It's a fittingly stunning mission for our 750th episode.
It was a real honour to be looking after the Strand to make the 750th show. And as you'll see, the science of the style of how we make the telly has changed a little bit in 50 years, but the theme music never does. Now, the telly bit of this film was very, very simple. We needed and wanted to go in more depth. The news would cover the story, and of course news were all over it. But we have two amazing presenters, Dr. Maggie Adarin-Pocock and Professor Chris Lintott. And we wanted to go behind the scenes, to be with the scientists and to share the excitement and bafflement of scientific discovery, to be able to be with them alongside. And it proved to be more dramatic than any scripted drama could ever be. And to be alongside scientists like Carly Howard and Jeff Moore and John Spencer as they uncovered these incredible images of these mountains made of water ice, that plain in the middle of the heart with these strange little lumps and a complete lack of craters, the canyons stretched across the middle of the moon, Charon. It was baffling to them. And the idea that these two bodies that they thought were ancient could be geologically active turned everything they thought about the way the solar system formed on their head. The idea, and they think they might be much younger than expected, maybe less than 100 million years, which is practically fetal in planetary body terms. So to be with them alongside, and to be alongside them proved to be brilliant television. But unravelling and making sense of that was quite tricky. Normally, if I tell you it normally takes us 2 months to edit a film, and we had 3 days to edit this and to make sense of the science alongside the scientists as they were doing, it was tough. You know, there were very long nights in the edit with an incredibly dedicated team of people bashing their heads together trying to work out how to make sense of it all. And they did an absolutely brilliant job. And crucially, the audience loved it. As I said, it doubled the normal BBC 4 audience numbers for this show. We were the third or fourth most popular website on the BBC. We had massive Twitter and Facebook followings. And most importantly for me, in a speech to all the industry leaders at the Edinburgh Television Festival this year, Amanda Iannucci, who recently was picking up Emmys for Veep and The Thick of It, singled out one show of all of the BBC's output in the last year to justify why we should keep the licence fee, and it was this Sky at Night special. I was incredibly proud. But BBC Science does far more than just the Sky at Night. It's just a fraction of what we do. There's all sorts of other shows about health, but in terms of space, we do Stargazing Live, we've got the Wonder series that we do with Brian Cox, and of course, Horizon. And the same passion and dedication of the team that made Sky at Night works across BBC Science. To keep finding great stories, good content, and new ways to tell them, to bring a new audience to science. We aim to entertain, inform, educate, and inspire. And there's good evidence that we are successful in that. In the 2010 BBC Year of Science, we know that the number of undergraduates applying to do science courses increased. That stuff is important. Now, at the heart of BBC Science's output is Horizon. It is the gold standard of science broadcasting, and no one else in the world does what we do. We sell globally, and we have content, we have output deals on Science Channel in the States. And our worldwide reputation is built on the integrity and quality of our science journalism and the power of our storytelling. And like Sky at Night, we're self-commissioning, which means we get to choose which programmes we make, what's in them, what they look like, and what they say. That means, with the editor Steve Crabtree, I literally have the best job in the world. Now, I'm going to talk you through some of the space films we've made this year and why and how we made them. You know, choosing what to cover in this big universe of ours is, quite frankly, it's really tough. But as I said before, there are three things we look at. First and foremost is the science journalism. This is at the core of what we do. And whether it's a film non-science based, like is binge drinking really that bad for us? And it is, unfortunately. Or something cosmologically mind-bending, like which universe are we in? The quality of the research that we cover is key. Peer review is in our DNA. It is absolutely key to what we do. But that's not enough to engage an audience. Critical is a storytelling. What's the story? Why should the audience give you an hour of their time? Why should they care? And thirdly, what's the form? What's the telly side of it? And the germ of an idea can start with any of those three things. I want to tell you about one of my favourite shows this year. We knew this year that CERN was going to restart the Large Hadron Collider with double the power. We wanted to make a film about that, and we started exploring what we hoped it was going to, or what it was hoping to discover. There's a whole load of more work around the Higgs boson. We've covered that a little bit. We thought, was there anything more that we could look at? Now, we knew it would be tackling one of the big mysteries of the universe, what 25% of it is made of. It's a thorny issue of dark matter, and it's a weird world of theoretical machos and wimps and supersymmetry. It's sort of rich with possibility, but what was the story really? How were we going to engage an audience with it, and what on earth were we going to film? We brought on one of our most talented directors, a chap called Peter Leonard, and it became clear that the reason to care, the real story, is that if scientists can't find dark matter, and if CERN can't validate supersymmetry theory, then not only does the standard model of particle physics we were talking about earlier fall down, potentially, but so does our understanding of cosmology. And that's a much bigger story than just CERN, the biggest and largest experiment on the planet, and dark matter, what the 25% of the universe is made of. We, scientists who are able and happy to work with our vision, however strange and wonderful, we're reliant on access to the very best scientists in the world and the very best institutions like Cambridge. Without their help and your help here, none of what we do is possible. Now, even interviews with the best scientists in the world will only take you so far in making a film. And being with them on location, enjoying their, sharing their emotions at the discovery, as we did with Sky at Night, will only take you so far. Sometimes you just need to see what they're talking about. And that can be hard when it all happened 13 billion years ago. Now, many of you, I'm sure, are aware that this is the International Year of Light. And following the discovery of one of the earliest stars from the Sky Mapper telescope in Australia last year, we were keen to do a film about the first stars. Great content. There's new technology enabling us to see further and further back in time, pushing at the boundaries of what we know about what's called the Dark Ages. And a great story. How did the first stars form? How did light and all the atoms that you, me, and this tent are made of, how did they form in the Dark Ages all those billions of years ago? It's the true creation story. But how do you film that? How do you film the Dark Ages before light existed? It's tough. But in the right hands, it's incredible what you can do with a smoke machine and a whole load of black ping pong balls. I want to show you a clip from behind the scenes of our Cosmic Dawn film, and I'm really hoping this one's going to play. Please say yes, because otherwise my talk's really boring. Yes.
Beautiful.
Yeah.
That chap at the end is the director, Toby MacDonald. Utterly brilliant. Now, in its raw form, a dustbin and some ping pong balls might seem a little underwhelming, but the directors on Horizon are narratively and creatively the best in the world. Toby had a vision for this film, and as you can see, it doesn't necessarily need to include a high budget, which is, we're the BBC, we want to give you value for money at all times. But I want to give you a taste of how his finished film ended up looking, because it's stunning. Let me show you.
In the beginning, the universe was a bit of a letdown, really.
For millions of years after the Big Bang, things were actually rather boring. It's just this soup.
The Big Bang was not the moment of creation.
The real moment of creation came 100 million years later.
There was this magical, if you like, metaphysical moment.
The cosmic dawn.
The moment of first light.
It's the moment the first stars were born.
The first stars are fundamental to how the universe evolved.
They're like the rock stars in the universe. They live fast and die young.
The moment that lit up the universe.
For the first time in cosmic history, the universe really is getting interesting.
And began forging the ingredients that made you, me, and everything around us.
It was the starting point that led to the appearance of life.
Astronomers are now trying to witness and understand this moment of creation.
I guess what we're trying to achieve is see the beginning of things.
We are dealing with the scientific version of the story of Genesis. Let there be light.
It's a beautiful film with stunning visuals and great science. Now, to sum up, the world around us is changing incredibly fast. I don't have the vision of Arthur C. Clarke, and I don't know what the BBC will look like in 3 to 5 years, let alone 50. But I will tell you this, in whatever form it takes, I and the rest of BBC Science will be working incredibly hard to ensure that Horizon and Sky at Night continue to evolve and adapt to deliver great science to the nation. Thank you.
So the same pattern again. So if you've got questions, if you've got ones written down, then we should really give priority to the ones who pre-book questions. But if not, then wave your card up in the air. So if you can see where there's one just there, just behind you there, just by the door, to your left. So that's it. So what's Horizon and Sky at Night going to be doing in 2019?
Oh gosh, I have no idea. Great stuff, hopefully.
Okay, so question over there.
It's pretty clear at what college you should go to if you want to become a producer of Horizon. Could you tell us what tripos we ought to read? And could you perhaps extend that question, what tripos is good if you want to become a member of the team that you were telling us about, which you think is world-beating?
Well, I can tell you, it's interesting. I read natural sciences and biological anthropology. I was interested in animals at the time and primates. The current editor of Horizon didn't get O-levels. He is one of the most talented filmmakers and editorial brains I've ever met. And he spent the time that I was doing A-levels at university painting nuclear submarines. So I think the BBC has had a reputation, and certainly in the science department, most of our researchers, or a huge number of our researchers, have got PhDs in all sorts of stuff. But it isn't the preserve of Oxbridge anymore, and I don't think it should be, because I think there's a lot of very bright, intelligent people out there who haven't necessarily had the advantages that many other people have had. And the BBC is open to that, and it's open, it's a meritocracy, and I hope it continues like that. I don't know if that answers your question.
I have a question here.
Hi Zoe, it's Stephen Allett here. I think many people in the audience will agree with me when I say that the BBC, the Horizon programme, and you yourself are national treasures.
I'm not sure I'm old enough for that, am I?
What can we do in our positions in our life and careers to help support the continued existence of the BBC in its current form, Horizon, and in fact, your team?
Oh, that's a huge question. Gosh. It's undergoing a period of change. We all know the licence fee is being looked at the moment. There are big changes going on internally as well. I don't want to air dirty laundry. All I can tell you is that internally science is really loved and lauded. The Director General is fully aware of the importance of the science department and what we do. There is a commercial world going ahead internally. BBC Productions we lose the licence fee guarantee, and we're becoming a commercial organisation in terms of BBC Productions. That will have a knock-on effect. But as I said, the Director General is fully aware of the importance of BBC Science and what we do. In terms of the BBC in general, it's the power of the people. I really hope that whatever funding models go forward, that the sorts of programmes that we make continue to be supported by the public, and that's what we need to happen.
Hi there. You mentioned a couple of times that the viewing figures were great for your programmes. Do you also look at what the demographics are? Are you actually attracting young people away from their mobile devices to actually watch these programmes? Yeah,
well, it's really interesting. It shows you how much I've worked in telly for nearly 20 years. I thought I knew everything. Turns out I know absolutely nothing. It's like having children. The more you have, the more you realise you don't know anything about children. We've been getting a breakdown of what the underserved audiences, whether that's at BAMEs or whether that's in the 16 to 34 audiences. And I'd always thought Horizon was a bit of a dinosaur. Whereas we were ABC 1s, over 50s, over 60s. Not that there's anything wrong with being 50. But actually, when you look at the underserved audiences, we get a surprising number of 16 to 24s. We overperform on that slot. I'm sorry for talking BBC speak, but that's actually really important. The entire nation pays for us, and it's really important that we serve the entire nation. So I do spend a bit of time looking into the figures. And we do reach a surprisingly large, younger audience, and depending on shows, a surprisingly diverse range, whether that's across socioeconomic group or whether that's across ethnicity. Far more than I had expected. And we are working, we do a lot of our reach online is really big as well. We get I can't remember if I said in my speech or not, it all got a bit jumbled up here. But we get a 30% uplift online for people to come and watch the shows, which is massive for the BBC. We are regularly in one of the top slots for the iPlayer viewers. So yeah, we're doing pretty good actually.
A question here, yeah.
I've noticed in the last couple of years the public awareness of particularly European science missions like Rosetta and New Horizons has increased a lot. And I work for the European Space Agency, and I've been really happy to see the shift. When I started there 15 years ago, nobody really knew what ESA was.
Yeah.
I think a lot of that is to do with programs like Horizon and Sky at Night that have really stepped up the broadcasting. Do you think that there's been a shift in the attitude of government agencies and the industry that's helped as well, or?
I don't know. It's difficult to say. I mean, I can't talk for government agencies. Gosh, certainly the scale of the ambition of the missions of ESA are brilliant. I mean, Rosetta's a classic example. It's bonkers, brilliant, wonderful to travel all that way and land on a comet. Utterly brilliant. And as you know, Sky at Night was there working with the team and did a very similar show to the Pluto one. We're working with them again. One of the clips I wasn't allowed to show you but desperately wanted to is we're working with ESA and the UK Space Agency at the moment. Tim Peake, the first British astronaut, is going up on December the 15th. We have been following him every step of the way. Amazing imagery looking at what it takes to become an astronaut. And again, one of those first-person, present-tense narratives where you're with them as you see his preparation to go up, and that'll air. I think we've got a slot actually the night of launch. It should be a really, really good show, that one. And we've been working really closely with ESA. So, hopefully that will continue. And I think it's the scale of the ambition. And also you've got great scientists and great comms teams. It's brilliant.
Excellent. Thank you very much.
Thank you.